helpful to be part of a community where you can talk to and bounce ideas off others. But inside such a mathematical community, it can sometimes be difficult to come up with that one idea that completely challenges the status quo. And then the breakthrough often comes from somewhere else.
Mathematics can be done in some pretty weird places. I'm in Transylvania, which is fairly appropriate because I'm in search of a lone wolf.
János Bolyai spent much of his life hundreds of miles away from the mathematical centres of excellence. This is the only portrait of him that I was able to find.
Unfortunately, it isn't actually him. It's one the Communist Party in Romania started circulating when people got interested in Bolyai's theories in the 1960s. But they couldn't find a picture of János, so they substituted a picture of somebody else instead.
Born in 1802, János was the son of Farkas Bolyai, who was a maths teacher. He realised his son was a mathematical prodigy, so he wrote to his old friend Carl Friedrich Gauss, asking him to tutor the boy. Sadly, Gauss declined. So, instead of becoming a professional mathematician, János joined the army. But mathematics remained his first love.
Maybe there's something about the air here, because Bolyai carried on doing his mathematics in his spare time. He started to explore what he called imaginary geometries, where the angles in triangles add up to less than 180. The amazing thing is that these imaginary geometries make perfect mathematical sense.
Bolyai's new geometry has become known as hyperbolic geometry. The best way to imagine it is a kind of mirror image of a sphere, where lines curve back on each other. It's difficult to represent it, since we're so used to living in space which appears to be straight and flat. In his hometown of Tirgamuris, I went looking for more about Bolyai's revolutionary mathematics. His memory is certainly revered here. The museum contains a collection of Bolyai-related artefacts, some of which might be considered distinctly Transylvanian.
It's still got some hair on it. It's kind of a little bit gruesome.
But the object I like most here is a beautiful model of Bolyai's geometry.
I mean, you've got the shortest distance between here and here. If you stick on this surface, it's not a straight line, but this curved line which sort of bends into the triangle. So here's a surface where the shortest distances which define the triangle add up to less than 180.
Bolyai published his work in 1831, and his father sent his old friend Gauss a copy. Gauss wrote back straight away, giving his approval. But Gauss refused to praise the young Bolyai, because he said the person he should be praising was himself. He'd worked it all out a decade or so before.
Actually, there is a letter from Gauss to another friend of his, where he says that I regard this young geometer Bolyai as a genius of the first order.
Yeah.
But Gauss never thought to tell Bolyai that, and young János was completely disheartened. Another body blow soon followed. Somebody else had developed exactly the same idea, but had published 2 years before him, the Russian mathematician Nicholas Lobachevsky.
It was all downhill for Bolyai after that. With no recognition or career, he didn't publish anything else. Eventually, he went a little crazy.
In 1860, János Bolyai died in obscurity. Gauss, by contrast, was lionised after his death. A university, the units used to measure magnetic induction, even a crater on the moon would be named after him. During his lifetime, Gauss lent his support to very few mathematicians. But one exception was another of Göttingen's mathematical giants, Bernhard Riemann. His father was a minister, and he would remain a sincere Christian all his life. But Riemann grew up a shy boy who suffered from consumption. His family was large and poor, and the only thing the young boy had going for him was an excellence at maths. That was his salvation.
Many mathematicians like Riemann had very difficult childhoods, were quite unsociable. Their lives seemed to be falling apart. It was mathematics that gave them a sense of security.
Riemann spent much of his early life in the town of Lüneburg in northern Germany. This was his local school, built as a direct result of Humboldt's educational reforms in the early 19th century. Riemann was one of its first pupils. The head teacher saw a way of bringing out the shy boy.
He was given the freedom of the school's library. It opened up a whole new world to him. One of the books he found in there was a book by the French mathematician Legendre, all about number theory. His teacher asked him how he was getting on with it. He replied, "I've understood all 859 pages of this wonderful book."
It was a strategy that obviously suited Riemann because he became a brilliant mathematician. And one of his most famous contributions to mathematics was a lecture in 1852 on the foundations of geometry. In the lecture, Riemann first described what geometry actually was and its relationship with the world. He then sketched out what geometry could be, and mathematics of many different kinds of space, only one of which would be the flat Euclidean space in which we appear to live. He was just 26 years old.
Was it received well? I mean, did people recognise the revolution?
There was no way that people could actually make these ideas concrete.
Right.
That only occurred 50 years after this, 60 years after this, with Einstein.
With Einstein. So
Yes.
this is the beginning, really, of the revolution which ends with Einstein's relativity.
Exactly,
in here.
yes, yes.
Riemann's mathematics changed how we see the world. Suddenly, higher dimensional geometry appeared. The potential was there from Descartes, but it was Riemann's imagination that made it happen.
Well, he began without putting any restriction on the dimensions whatsoever. This was something that was actually quite new in his way of thinking about things.
And somebody like Bolyai was really thinking about, new geometries, but new two-dimensional geometries.
New two-dimensional geometries. Right. Riemann then broke away from all the limitations of 2 or 3 dimensions and began to think in higher dimensions.
Right.
And this was quite new.
Yeah.
Multi-dimensional space is at the heart of so much mathematics done today. In geometry, number theory, and several other branches of maths, Riemann's ideas still perplex and amaze. He died, though, in 1866. He was only 39 years old. Today, the results of Riemann's mathematics are everywhere. Hyperspace is no longer science fiction, but science fact. In Paris, they've even tried to visualize what shapes in higher dimensions might look like.
Just as the Renaissance artist Piero would have drawn a square inside a square to represent a cube on the two-dimensional canvas, the architect here at La Défense has built a cube inside a cube to represent a shadow of the four-dimensional hypercube. It is with Riemann's work that we finally have the mathematical glasses to be able to explore such worlds of the mind.
It's taken a while to make these glasses fit, but without this golden age of mathematics, from Descartes to Riemann, there would be no calculus, no quantum physics, no relativity, none of the technology we use today. But even more important than that, their mathematics blew away the cobwebs and allowed us to see the world as it really is, a world much stranger than we ever thought. You can learn more about the story of maths with the Open University at open2.net.